Hey guys, and welcome back. So now we're going to talk about volumes in Houdini and how we create volumes and how we convert geometry into volumes. But before I do that, I want to explain what a volume is really. And so let's say we have this a cube, for example. The way we convert this into a volume, or Houdini converts this into a volume, is by creating lots of small cubes to fill out the entire bounding box of this object. So if I put down a bound node here, this is the let me view this. So this is the bounds of this tube. The volume is made of lots of small cubes put together one after the other, and it's gonna look like something like this. If I view wireframe mode, I need to put down a null. Sorry. Yeah. So this is the cubes that put together one after the other, and they are all combined to create the volume. And then in these cubes, Houdini will start putting information where the geometry exists. So if we have the tube here, for example, it's gonna put a value 1 here, a value 1 here, a value 1, and then it's gonna put down 0, 5, for example, in this guy. And so it's gonna try to represent the geometry of the tube using these cubes. Okay, and what these cubes are they're called voxels, and lots of voxels is what make up a volume basically, and that's how it works basically. And you will always have voxels in a defined domain, and then that defined domain will basically only have values where we have geometry, or where we need information. So if you have explosion here, you'll have only data stored in the voxels that define that explosion. Okay, and then everything else will be empty. And so Houdini has two types of volume: the old Houdini native volume, which is less and less used, and the new one I think was introduced in Houdini 13, and it's called VDB volumes. And so we're going to be using VDB volumes throughout this course entirely. And so how do we create them? If you hit tab, there's a whole section here called VDB, and this is where you have all the nodes that you can use to create volumes and convert geometry and points into volume. So what we're going to do is we're going to take this tube, and let me convert it to a polygon, and I'm going to add subdivision, and I'm going to put down a VDB from polygon, node, and this, the first input is the polygons to convert. Okay, if I view that now, I have this weird view, and what this is it's an actual volume, but it's of different type. This is called an SDF. We're not going to be using this for now, and we'll learn more about it once we get to the fluids section. So instead, I'm going to uncheck this distance VDB surface, and I'm going to uncheck it. I'm going to click fog VDB density, and now let me change the viewport to black, and now we have a volume representation. And this voxel size is actually the size of the cube that we talked about here. The smaller the cube, the more details we can have in the volume, and you can see that here. So if I make the cube smaller, that voxel smaller, it's going to be able to describe the geometry in much more defined way. And if I put down a VDB visualize tree just to show you guys, and click view, this will show you the domains that the Houdini or VDB algorithm decides to put information on. And this VDB format is very optimized, and it only stores data where it needs to be, and everything else is basically empty. And so this volume visualize here is showing you that we only have data in there, and then these guys are empty. but this box here is not the voxel. It's just the domain where it thinks there is no data and where it thinks there is data. And if you want to show the voxels, you can choose active voxel and change them to solid box. It's gonna take some time, but hopefully, let's see. Okay. It's gonna take some time to display because yeah, that's a lot of voxels. So if I hit W, you can see that's the size of the actual voxel that we specified, 0.014. Cool. So there is that. I'm gonna disable the view, and so now we can take any geometry and convert it into a volume. So let's do that. I'm gonna do a VDB from volume from polygon, and I'm going to convert the box, the wall that we had, into a density volume, and then I'm gonna scatter points in that volume. And so now we have points inside the volume as well, not just outside. And if we use that, we'll be able to get more details inside versus, let me do a switch. So this is before and this is after, and this is before and this is after. And you can see we have more details here, but there is more details as well on the interior. And if we increase the point, we'll get much more details as well on the interior side. So this is the way we're going to be fracturing pieces. We're going to be converting them into volume, scattering points in the volume, and then combining that with a fracture sub. Cool. So the next part is the constraint, and I think it's time to start doing some RBD example. And so my idea is we're gonna go through this workflow with a simple mesh first, with no fracturing, and just understand how the constraint works, and then pass in the geometry and the constraint to the RBD and understand how things work. And then we'll reapply that same knowledge and add more stuff to it in our real example. Cool. I hope you guys like this, and see you in the next video. Bye bye.